everyone. Welcome back to our channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Pablo, who has completed the ROS2 Basics in Python in 5 days. And today he's going to be showing us the final project you have to do in our course in order to solidify this learning path that we take you on for the course ROS2 Basics in 5 days. So, hello, Pablo. How are you?
Hi, I'm very good.
Good to hear. Good to hear. So, yes, whenever you want, you can start sharing your screen, and then we can take a look at the project you've done.
Okay. Do you see my screen?
Yes, we can see the robot and the cameras and the terminal you have open.
Okay, very good. So the first thing you have to do when connecting to the robot is to use ROS bridge. So this is the command I have already run here in the first terminal.
Nice.
So once you have done that, then you have to run your ROS program in another terminal. Okay, so I've already properly located kind of my robot. So it's kind of the middle of the road, and right now I'm going to launch my program.
All right.
So the first thing the robot is going to do is to look for the wall, the nearest wall. So that is done checking the laser data and checking the lowest value in the readings. Okay, so
Okay.
once okay, so this camera
I
is
think the
stop.
left camera froze. Oh, there we go.
Yeah,
It started up.
Linux things. So once the robot has already found the wall, it starts following the wall, checking. In my case,
Mm-hmm.
two larger data. So the immediate right, left, immediate right laser, and a close laser to check to better follow the wall. So
Right.
at the beginning with this project, I found that sometimes the robot had little problems following. Sometimes, not always, but little problems following a straight line when the wall is straight.
Uh-huh.
So I finally found that one way of doing that, doing better that following method is to add another to compute another laser data laser and by checking an ideal measuring and the real measuring, we can adjust more or less the following pattern.
Mm-hmm.
So yeah, let me say that sometimes, so the speed for some people, or it seems not very fast, but
Uh-huh.
that is a choice because the program was much better when the speed is lower.
Yes, yes,
So
that makes sense.
because yeah, very good. So
Oh, it
now
finished down,
he has
right?
reached the all again the beginning position.
Mm-hmm.
So when it gets to the final position, it counts. It sends back all the points that the robot has reached, and the final distance. Okay,
So
so
that's all the points that the robot traveled through.
yeah, yeah.
Okay.
So I've prepared an easy presentation, and a very simple presentation to explain better my program. Okay,
Great.
so now I'm going to show you. Okay, I hope you see. Do you see my?
Yes.
Okay, very good. So the road we are using is Turtlebot 3, that was originally made for ROS2, ROS1 noetic, but we are using, of course, ROS2, and for connecting both ROS1 and ROS2, we have to use ROS1 bridge. We have a velocity limitation. If we get over that velocity limitation, the program stops and the communication stops. So we have to not try not to get over that limitation. Also, that's very important because you may have seen in other presentations, the laser scan data is differs from the simulation. Okay,
Yes.
so the simulation is, I think, 360 degrees, 360 rays, and the real robot has a range of 720 rays. How do I know that? Because, well, at first it doesn't work, but I used ROS2 back
Oh.
for saving the rays and also analyzing the data for improving the code also.
Mm.
So front the front laser is equals to 360 ray of the laser scan. The left 540 and the right 180, and the back laser is 0. So we have three nodes, well, three programs with three nodes running at the same time. We have the wall following behavior, the location service, and the odometry record action. So the main program is the wall following behavior that calls the location service and also starts the record action. That is a action server. So yeah, this is very small to read, but okay,
It's the
this is the
logic,
whole
no?
program of the wall following patch program. Okay, so we have in the wall following algorithm, we have that at first we check that if the location server has already done its service or not. Okay, so if not, it send a request. If and when the action server the location service gets its position properly done, it sends back a response, and then the program continues. Okay, so once the program continues, it starts following the wall, and then and also at the same time gets the odometry record started. So we have an above and below limits related to the wall. So we have the laser wall 2.3 meters, and when it's higher than 0.3, we have to get closer, and when it's farther than 0.2, we have to go further. The thing is that if we only take into account those two limits, the robot is going to like a bounce. Is going to do like a bouncing. So I have also added a pattern that is the robot between 0.2 and 0.3. It tries to get to all the time follow a triangle, uh, a triangle of two rays. Okay, so it's only a very simple math problem. So we have two rays, the right ray and the right ray, and another one that makes an angle, and we are counting the difference between the relative error between the ideal reading and the actual reading. So when the actual reading gets below or upper the ideal read, we have to correct it. So it's only that that the thing that does the robot to behave a little bit better.
Right.
So we have a similar method for the wall following pattern, but in this case, firstly we have to know the the closer ray and orient the robot to be at that ray. Okay, so that once that it gets closer and then it turns right or left. Well, it's our left to have the wall at their right side. Okay, so I hope is I'm explaining well.
Yeah. Yes.
Finally, the action. Yeah, I don't read action server. Yeah, the odometry. Firstly, we have to get the odometry info. Then it gets passed to a function, Euler from quaternion function, and that with that function we get the angle and also the well all the info. Well,
Mm-hmm.
I think that function no. Well, then we have a while loop. I don't like while loops, but I try to not to use while loops. I try to use I tried using ifs. No, in this case, I think it's mandatory to use while loop. Um, well, the while loop checks if the whole distance it well checks if the distance between the final position, the actual position, the instance position, and the first position is less than zero point 0.1. Okay, so now I have to say that in the course, they say, you say that we have to get closer than 0.05. And in my program, I get that distance right most of the times, but not always.
Mm.
Why? In my experience, is because the computation frequency, not always the distance matter. Okay, so we are only checking the distance once
Every
a
second.
second.
Yeah.
So that is a very low frequency,
Mm.
and also gets error when when computing the whole distance too. I tried uh, several methods of not using the time function of Python. I tried to compute the distance as fast I could, but that gave me problems. So finally, I thought that it must be is better to get a wider error
Mm.
and to get it working, but instead of having a not functional program that checks the distance very fast.
Right.
So when the condition is reached, when finished, it sends the result to the client and the robot is stopped. How in the main function we get that with elif self dot res well found is true and self action result equals 1. So finally, to speak about the problems that some of them I've already talked about, but to summarize, we have mostly two problems in my experience. The first one is accuracy. We have the difference between the simulation and the real model, and that gets up us to make the robot to move slower. Uh, Also, we have the computing frequency problem that I've already talked about,
Mm-hmm.
and maybe for I'm sure is the algorithm can be a lot better, I think to if we want to do a simple algorithm, it's difficult to follow a wall very good if without taking into account uh, statistical methods
Mm.
that I don't know. And also I have had some multi-threading problems because as I'm not uh, at the point of right now of mastering the multi-threading
Mm-hmm.
because for me in my experience is very uh, touchy, very it's very difficult to treat it very well in ROS2 because if I add some things, maybe I get the odometry node to not running.
Mm.
So it has been a it's not so easy in my experience. So I don't know if it's my problem, but multi-threading I think is difficult. But it's mandatory for doing a not so simple program. Okay, so thank you very much for hearing me. The
All right. Great. Do you mind stopping sharing your screen so we can
okay,
look at each other here? Well, congratulations, Pablo. Really nice presentation. I really like your diagrams for your logic. That means that usually means that the program is going to come out more complete, let's say, and really good. And yeah, you were saying of the problems you had of multi-threading. Well, um, you must have used them correctly in order for that behavior to run. Otherwise, the robot would keep going because the laser callback would get blocked. And but yes, I agree that it's difficult to understand. But as long as you get the objective done, that is good. Um, Let me just ask you one question I had about the. You said you used a ROS2 bag. Can you just tell us a little bit how you used it? And sorry if you need to share the screen, you could share just because it's really interesting because it's very helpful to use ROS2 bags, and I'm happy to hear you are using it.
okay. So I used it like 2 weeks or 3 weeks ago. So maybe I'm going to say I'm not good to be very accurate, but yeah, roast
Or the
to back
point at least.
is
The
the way,
mm-hmm,
as far as I know, the way of saving some topics or some info that Rose is publishing into files. So yeah, at first I thought, well, I have a laser, I have a robot. I want the robot to follow a wall uh, with the laser. Okay,
mm-hmm,
so the best way, the easiest way, is to know what is the laser saying. But if you echo the laser in the terminal,
yeah,
you're going to see that a lot of let me share with
mm-hmm,
you.
yeah.
So yeah, so for example, if yeah,
We can
do you
see.
see
Yes,
my
we can see.
screen? Yeah, I think so.
Yes,
Right? Okay.
yes, yes.
So yeah, so if I do rows to topic list, and here you can see the topic. So if I do rows to topic echo scan, so I don't know you, but I'm not capable of reading this
Exactly. Yes.
this this info in real time. So what I did, I think the command is to back, and I don't know. Well,
Record or something. Yes.
yeah.
Yeah.
The thing is that it gets the file to the topic it gets the topic saved into a file that then I have to convert it to an Excel format.
Okay.
And then in Excel, I think I have here. Uh, I may have one of the original. Uh, I think scan. Yeah. Um, scan two. Mm.
Oh. Well, but we would have all the readings right there of the
Yeah,
lighter.
of course.
Uh-huh.
So well, after managing the Excel, so you have to to place the info in a proper way. Well, then I analyzed the data and I found that the best way I found is to use a very simple triangle,
Yeah.
and you only have to compute the relative error. I think in my program I do it with I don't remember properly. Okay, so is yeah. So we have the readings, the actual readings here.
Yeah.
Okay, so we have. I think I don't know if I can make it bigger, but well, we
No,
have
we
the
can see.
actual readings, and we have here the relative error computing. So we are I don't know how to say in English to rest
You're just subtracting, yeah.
to subtract. Yeah, to we are subtracting
The upper minus
the upper. There is only array that is slightly upper. So,
right, I
so
see.
the yeah
And the one that's right on the right
yeah
side so you can see how much it's deviated.
yeah. So as I know the relationship, the relative error that it has to be reached, I can correct to to the right and to the left. So yeah, you see that if it's higher the relative error than 0.02, it gets to the we have to correct to the right, and
Mm,
if it's less, we have to correct to the left. So it's only a matter of a triangle.
right.
It's not that hard. But yeah, you are right because ROS2 is is not. I've been with Ross like with for some time,
Mm-hmm.
for some months, and until like this month I didn't know about it. So I think Ross Chubach with sensors, with some, it's the most useful tool you can use, because until you use Ross Chubach and you have the actual you have the actual data, you are kind of blind
Yeah.
with what you're doing, because you don't know exactly what you are doing. You must know exactly where the data is showing and what is not. So because for example I check the laser data, and laser is not always very. It's sometimes I get errors. Sometimes so it's not always the same.
Yes, of course.
It's not perfect.
Yes.
So if you know that, you can take that into account. But if you don't know that, you can't. So that's for your
Yeah.
question.
Yes, yes, that's very yes, yes. ROS2 bags are very helpful, uh, and they're not very used. So instead of, for example, always testing on a simulation on a real or a real robot, in this case, you get the information that you need. You can even record everything: the TFs, the scan, the odometry, everything you need, and or select it, and then you can work on that data. Yes, it's very helpful. And last question I want to ask, though, you mentioned something that you put that information on an Excel spreadsheet.
Yeah.
Why is that? Like, what's the reason for that? What did you want to do by putting it on an Excel spreadsheet?
Yeah, firstly, I thought maybe I can see some patterns because I think because I thought I thought in a mathematical way.
Yes.
So I thought maybe I don't know, maybe I can take the function. I can do mathematical work to in order to understand what the problem is, because we all know what a wall is, but does the robot knows
Right. Right.
does the robot know? So the robot, what it sees, what is the data. It doesn't know if it's a wall, if it's a because of the first real robot experiences I had, sometimes you have a cone where it is not supposed to be.
Right.
And
Yes.
firstly, I thought I may be capable of doing a very simple behavior of avoiding some
The obstacle.
obstacles.
Yes.
Later, I saw that it's not that simple, but for that I use the ROS2 bag and all. I get the Excel. I show it in a function. But finally, it was much simpler because I didn't want to get very messy
Right.
because it's hard. It's not that easy.
Right. Okay. Yeah, I recommend also using RViz as long like to
Yeah.
help you out with visualizing and things like that. That's why I was just asking, just wondering why
Yeah,
you're using that.
but in my point of view, if you see the numbers, because RBs is very good, is amazing, but
You don't see the
uh,
numbers. Yes.
with ROS2 you can see all the numbers
Hmm.
exactly, not
Yes.
more or less exactly. And if you want to do a program well, you have to do well.
Yes.
I'm not saying I do well, but it's the proper ways to do is to do well in a mathematical way.
Hmm. Okay. Well, other than that, Pablo, congratulations again. I don't have any more questions. Congratulations. Really nice project, and
Thank you very
thank you
much.
very much. And to whoever else is watching this, this is what you can do when you take our courses. You can take a final project and present it here with us in order to obtain the certificate and to show everyone what you've really learned during our course. So thank you, everyone. Thank you, Pablo. We'll see you next time. Bye bye.
Bye.
Ok, perfecto.